I will start the class in 2 minutes. I hope my screen is visible to everyone. Uh, Actually, on my end, there is some power cut here, so that's why maybe you won't be able to see my face properly. But okay, this is only for this time. So I'll start the class now. So, good evening, everyone. Today is the eighth live session for the Polymer Reaction Engineering course. We'll be going through a few of the problems which will be helpful for you to solve your assignment number 8. So first we have here is what are some limitations of testing and sampling in polymer systems? Select all that apply. So different types of testing and sampling measurements which are made during the polymer system analysis, or if we were to manufacture a polymer, and if we are to test the standards or the sample integrity and all those things. So what are the factors which can affect the testing of the sample itself? So first we have is the sample variability, then environmental factors, size effects, test speed, and inherent material property. So first is the sample variability. So sample variability, what does sample variability mean? For example, if two people who are living in different countries follow a similar method of testing, and if their samples are slightly variable, that is, if person A has a polymer of thickness 1 mm and the person B has a polymer of thickness 1.2 mm. So that itself can create a lot of error in the measurement. Error in the sense like the entire polymer testing can be uh, will be affected because of that small change in the sample itself. So the sample variability is what uh, affects the testing and the sampling in polymer systems. On top of that, if you are, for example, dispersing something in the polymer system, for example, if we are putting some filler material in the polymer system, sometimes if the filler is not properly dispersed, the person A can have a different filler density in the sample, and the person B can have different filler density. And because of that, your the testing of the polymer system will be varied. So because of that, the sample variability comes into picture in that way. Next we have is the environmental factors. Next we have is the environmental factors. What happens in environmental factors is that, for example, if you are living in a country or if you are living in a place where the humidity is very high, so the water absorption of the polymer might affect the testing of the sample itself. So that's why it is very important to ensure that the environmental factors while testing are also maintained at a specific condition. These are some of the things which are followed while making a testing standard. For example, there are different testing standard agencies such as the ASTM, ISO, which are followed all over the world so that homogeneous testing results can be generated throughout the world. For example, for a similar polymer sample, if I am testing it in India and somebody else is testing it in the outside country, by following the same standard, you will get similar results. That creates a homogeneous baseline for all of the manufacturing and sampling of the polymer systems. Next we have is the size effects. Size effects, as I said, if the dimensions of the size itself are different, that will affect the limitations, that will limit the testing of the sample itself. And the size effect will change the geometry, and because of the geometry change, your properties will be varying. So sample variability, environmental factors, and size effects. These three are definitely going to affect your testing and sampling, and they can limit the results for the testing and sampling of polymers. Then we come to testing speed. Now, testing speed, for example, that may vary, but it should give the similar kind of result for all the polymer samples. So that's why test speed can vary, but it will ultimately generate similar kind of results. So since polymer materials are viscoelastic in nature, so testing speed will be accordingly adjusted, and if both are following the same test speed, same kind of result will be generated. So that's why it won't affect the uh, testing of the sample. Then inherent material properties. Inherent material properties, if two separate materials are being tested, definitely different results will be obtained. Inherent material properties of two samples, of both of them are same, then no problem. We will have the similar kind of results. So the first three, that is sample variability, environmental factors, and size effects are some of the limitations of testing and sampling in the polymer systems. Next we have is the which of the following direct shaping processes can be used for preparing test specimens. So we have been given four options here: injection molding, blow molding, extrusion, and compression molding. So in the last class itself, we have read about pretty much all of these manufacturing processes. So from which of these we can get a direct shaping process that will prepare our test specimen. So usually the polymer testing specimens are either cylindrical in nature or flat in nature. So these two kind of samples can be obtained by the following manufacturing processes. So first one we have is the injection molding. In injection molding, we are inserting the sample from one side, and from the other side we are generating the polymer manufactured product on the sample itself. So basically you're injecting the polymer and you can shape it in any way, and you can clearly shape it in the way your sample has to be tested. So that kind of sample coupon, the test sample for polymer and composites are usually called coupons. Small scale samples are called coupons. So these coupons can be generated by injection molding itself. So injection molding is definitely one of the answers. Then next we come to blow molding. In blow molding, what happens is that we are putting pressurized air in a miniature version of the sample, and that miniature version of the sample blows up like a balloon because of the heat and the air pressure. So once you generate the sample or the product, that product has to be cut down further, and it it cannot be generated in the testing specimen dimensions. So that's why blow molding is difficult. Blow molding process is not suitable for preparing the test specimen sample. So if you want to make a test specimen sample, you have to make the blow molding process and then cut a sample out of that, which might also vary because of the manufacturing process itself. So blow molding is not the correct answer for this. Then we have the extrusion process. Similarly to injection molding, in extrusion also, when the polymer is coming out on the other end, in either of the manner, that is cylindrical or rectangular, it depends on the kind of die you're using, the die for shaping the polymer. So because of the extrusion process also, you can make the test specimen according to the uh, testing dimensions. So extrusion is also one of the answers here. Then we have the compression molding process. Now, compression molding process also, as we can see from the name itself, it provides temperature and compressive force to make flat samples. Now, it is the easiest way to test the polymer specimens by creating flat samples. So, ready-made, we are getting the samples made from the compression molding process. So the answer for this question is injection molding, extrusion, and compression molding process. We can use it directly used for shaping of the process and creating of the test specimen for polymeric testing samples. Next we have is the which of the following instruments is commonly used for extensometry measurements. Now, basically, what are extensometry measurements? Any kind of extension or any kind of change in the length or the dimension of the material, which is either causing strain or the extension inside the material, is basically what is called the extensometry measurements. So basically, what is the main aim behind it is that the polymer materials, when subjected to some specific kind of pressure, sorry, not pressure, specific kind of change in dimension creates stress inside the body. So, for one clear example for that would be if you were to take a uh, plastic, uh, plastic coupon or a plastic pencil or anything, when you try to bend it or break it, there is some resistance to breaking and bending. That is happening because by bending or trying to break it, you are changing the sample dimensions. And because of the change in sample dimensions, the material is resisting that change in the sample dimension. So that is creating the extension inside the material, and that is what is called the extensometric measurements. So which are the materials used for? So we have is the tensile testing machine. Tensile testing machine or the universal testing machine is the machine which is used for measuring most, if not all, of the mechanical properties of the polymer or any other composite or any other metallic material. So that's exactly the reason why it is called the universal testing machine. So that what it does is that it produces either compressive or tension load inside the material, and because of that you will have the change in dimension, and it will record your stress and the elongation, and it will give you the modulus or any other property which you want. Similarly for the compressive force also. So for example, if you have the tensile testing machine, and if you were to keep a sample inside it, if you stretch it, definitely strain is being produced. Why? Because the change in length, that is the delta L divided by the original length L. So that strain which is being generated will cause the material to produce stress to resist that change in dimension. And that resistive stress is what is called the tensile stress of the material, or the uh, tensile stress of the material, and the change in length is called the strain or the elongation. Now, when the material breaks, there are other properties, like other properties or different names of the same property, such as when the material breaks, the strain, the maximum strain which it was able to handle is called the elongation at break. And the maximum amount of stress it is able to handle is called the ultimate tensile strength. So these are the parameters which can be tested using the tensile testing machine or the universal testing machine. Durometer is basically used for, it's a standardized way to measure the hardness of materials like rubbers or elastomers and plastics. And durometers range from the 0 to 100. But the thing is that durometers don't actually have any kind of, what should I say now, unit in itself. So basically, durometers are used just as a normal measure to check the hardness of the material. And then we have the micrometers. Micrometers are used for checking the dimensions, not the extension properties. Similarly, durometer is also only for the hardness and not the extension properties. Then we have the impact tester that is used for testing the impact strength of a polymer or any kind of material. What we basically do is we impact the material, and the amount of stress which is being generated in that instance is called the impact testing. So extensometry measurements are basically carried out by the tensile testing machine, which is the answer for this question. Next question we have is, what are the different types of rheometers commonly used for material characterization? So we have been given right here five examples. So first one we have is the capillary rheometer. Now, capillary rheometer is very useful in measuring many of the flow properties of the polymer itself. And for material characterization, capillary rheometer gives us the idea about melt flow index of the polymer. Now, what is melt flow index? Melt flow index is the amount of polymer which flows under a specific weight at a particular temperature. So that is according to the standards of the melt flow index, which needs to be tested. For example, at 60 degrees Celsius under 2 kgs, the polymer flows this much. So the amount of material which is coming out under that weight and temperature is what is called the melt flow index, and that can be measured using the capillary rheometer. So yes, capillary rheometers are definitely used for material characterization. Next, we come to the rotational rheometer. Now, what happens in rotational rheometer is that you have a sample and you're creating shear by placing the either flat plate or cone and plate assembly on top of the rheometer on top of your sample. So, as we know, using the Newton's law of viscosity and the amount of shear which is being generated, you can clearly observe the normal flow curve properties. How the rotation of the rheometer itself will create different shear rates. And already we know the relationship that tau is equal to eta du by dx, du by dy. With the du by dy, that is the shear rate, and the tau, which is the resultant shear stress, we already know. And from that, we can clearly observe the viscosity change with respect to increasing shear rates. So that can be done by the rotational rheometer. Then we have the dynamic mechanical analyzer. Dynamic mechanical analyzer is a different kind of measurement technique in which we are measuring the mechanical properties of the sample at dynamic rates or the changing temperature. Sometimes it is also called DMTA, that is dynamic mechanical thermal analysis. So basically, the mechanical property changes because of the thermal stimulations. So that's why dynamic mechanical analyzer, is not exactly a type of rheometer, but some rheometers can perform the dynamic mechanical analyzing test. So it is a specific test, but it is not a rheometer. So moving on to the next one, we have the universal testing machine. Now, just in the previous slide, I have explained universal testing machine is used for characterizing the material at any extension or tensile or compressive properties. So it is basically not a rheometer. So that's why it won't be classified in this answer. Now, last is the oscillatory rheometer. Now, what is an oscillatory rheometer? We basically know that polymers are viscoelastic in nature, which means that they have viscous properties like fluid and elastic properties like solid. So when you have mixture of both of them in a single material, what it does is it creates like complexity of the measurement itself, and that can be only resolved using the oscillatory rheometer because viscoelastic properties are time dependent, and oscillation is also happening with respect to time. So the oscillatory rheometers create time dependent frequency deformation in the polymer itself, which helps in the measurement of the viscoelastic properties. So these three rheometers, capillary, rotational, and oscillatory rheometers, are used for material characterization of the polymer samples. So these three are the correct answer. Next we have is rotational rheometers can simulate and measure the flow behavior of material under various shear rates. Just exactly how I explained in the previous question. The answer for this is true. Next, we have the hardness test is a measure of a polymer's dash. We have four options here: flexibility, durability, resistance to indentation or scratching, and thermal conductivity. Now, just as I have explained about the universal testing machine, so the flexibility measurement itself comes in under that part. So universal testing machine can be used for measuring the flexibility. The durability or the toughness of the material again can be measured using the universal testing machine. So these two are not a part of the hardness test of the polymer. And what does the hardness test measure? Is basically the resistance to indentation or scratching. Basically, if the surface of the material is hard, So you won't be able to pierce it or indent it. Indentation is basically meaning that you can make a hole through it. So the durometer, which we talked about in uh, this question right here, the durometer. Durometer is basically used for measuring the hardness. So the hardness in so so the durability basically is measured by the resistance to indentation is what is measured by the durometer. So the durometer, it's a meter where there is a small needle. You try to press it into the polymer, and the polymer definitely resists the pressing of the needle. So that resistance is what is termed as the hardness of the polymer material. So there are different types of hardness analysis also. For example, in composites and polymers, there is something called Barkol hardness. That Barkol hardness is a specific type of hardness which is measured by the Barkol hardness tester. So that is also a resistance to indentation or scratching. Now, thermal conductivity of polymer, definitely that is not the answer for this one, as we know that the thermal conductivity of the polymer itself is not a testament to the hardness of the polymer. The correct answer for this is resistance to indentation or scratching. Next we have is which figure of merit is used to measure the accuracy of a measuring system. So basically, it is asking us that the different standards and different measuring techniques which we have, what is the merit or what is the basis on which we are trying to judge the measuring system. So how are we doing that? So first we have is the precision. Now precision, what happens in precision is that how precisely you can make the measurement. How precisely you can make the measurement is basically meaning that how many times can you repeat the same measurement and you can have the similar kind of value. So that is the precision of the measurement. Next we have is the sensitivity of the measurement. Now in sensitivity of the measurement, how sensitive is your equipment with which you are measuring the polymer or the composite material. What is happening in sensitivity is that basically how well it can adjust to any kind of change in the circumstances or change in the dimension. So how much is the sensitivity of the equipment itself? Then third one is the resolution. Resolution means that till what significant figures the measuring system is generating the results. Basically, that is the resolution. And last is the bias of a measuring system. Now, the bias of a measuring system is the main factor uh, which tells you if the system is properly measuring the material's properties or not. So, bias in measuring system is the basically what is termed as the accuracy of a uh, accuracy of a measuring system. And bias is the only figure of merit which should be observed when measuring the when assessment of a measuring system. So that's bias. Basically, how I can explain the bias is that, for example, if you have manufactured a polymer with a die of 2 mm, okay, so the thickness of the polymer is 2 mm, basically. So that is the true value of the sample. That is the exact true value of the sample. Now, example, your measuring system is a vernier caliper or a screw gauge or anything. Okay, you are trying to use these and you make repeated measurements at the different points inside the sample. For example, point A, B, C, D. If your material is a long cylinder or a long rectangle, you divide that into three portions and you divide it as A, B, C, D, and then you measure the thickness at these three points. So the thing is, your accuracy will be judged, accuracy or the bias will be the measure of distance between the average value of these measurements and the true value of the sample itself. Mind you, bias is not equal to precision, it's not sensitivity, and it is not resolution. Precision, sensitivity, resolution are basically one part or the other same, but bias or accuracy is what we are trying to target in a measuring system. So that's why your bias is what determines your entire measuring system's capability of generating the equal homogeneous result for a true sample. Okay, so This week's lecture was more about the testing part of the polymeric products, and we learned about how the different testing standards were there and what are the factors which can affect the uh, polymer testing properties. So, if you have any questions, you can ask me.
Can you tell about some fill factor? Fill factor is a term used to describe the dash in a mold cavity during the injection molding process.
Okay, fill factor in injection molding process, right?
Yes.
Uh, yes, ma'am. So in fill factor, what happens is that it's an important measurement that you can use to evaluate the efficiency of how the mold is being filled. Basically, if your fill factor is low, which means that superficial filling of the polymer can happen while the injection molding is happening, and because of that, the polymer may not flow properly in that fill cavity. So your fill factor should be a bit high so that the material can properly flow into it and your injection polymer is produced in a better homogeneous manner. So that's what it is, fill factor. Uh, you have any other questions, ma'am? Uh, yes, Reshmi, you have raised your hand. So if you're trying to speak, your mic is muted right now. So you can unmute yourself and
Oh,
speak.
sorry, sorry. Yeah, yeah.
Yeah.
So in the direct shaping process, no,
Yeah.
actually, blow extrusion also, you have told it is a type of direct shaping, right? No, sir.
Yeah. It's direct treatment.
But in the lecture class, no, extrusion has been written under indirect shaping, sir.
Actually, yeah, because you can change the die shape itself, you can change, and because of that, uh,
Yes.
so if you are changing the die shape, you are indirectly basically shaping it. So that's why maybe it's called indirect one. In injection molding, what happens is you are sending the material through the screw gauge, and it is coming out at the other end from a singular opening. That is the gate. So that's why I would say that some would say that injection molding is a direct shaping process, but extrusion is also in some manner, also a direct shaping process because you can change the die shape and you can get the direct shaped material. For example, if you want to make a cylinder of, for example, X diameter, so you can get your material extruded out from the die of that X diameter, and you will have the sample ready directly with that. Okay. Your mic is off, so if you're saying something.
Hello.
Hello.
Uh,
Yeah.
so actually, this has come in one of an assignment questions, sir.
Huh.
So when we are answering, no, whether we have to follow that lecture class notes that which is indirect, or we can tick it as an answer.
You can take that as an answer. It's fine.
Oh, fine, fine. And so, what about this rotational rheometer that has not been mentioned there? Okay.
Oh, so it's not there. Okay. Okay. I'll explain it much better. If like I don't have the specific material for the rotational rheometer right now, but if you want me to
No,
explain
does
it
it
in a
come under? No, does it come under direct or indirect, sir? Rotational.
rotational, will come under direct only. It's not a
Okay, okay.
shaping.
Molding.
It's it's
Yeah,
not
yeah.
a it's not a shaping method. It's just for measurement.
Okay, okay. So extrusion also we can classify under that. That's what you mean, no, sir?
Yeah.
So that was a doubt which I was having, because in the notes, it was clearly classified and written that extrusion is coming under indirect. So that's why I had a doubt.
Okay. Okay.
And one more thing, sir. Actually, this porability, the apparatus which we use for measuring porability was one of the questions.
Hmm.
So whether that flow cup comes under that one, because when we do refer to some textbooks, no, they say flow cups and all come under porability measurement.
Yeah, flow cup is
So,
basically what is used for porability.
but that melt flow index also comes under that, no, sir?
Yeah, melt flow index also comes under that, but they both have different purposes.
Yeah. Okay,
Okay,
what about
so
portability? Which one will be the apt one, sir?
flow cup, flow
Sorry,
cup is the flow cup,
that is for polymer bulk.
density measurement.
Uh, yeah.
Yeah, so the
No, that is a
portability.
polymer bulk. No, what is the apparatus which is commonly used to determine the portability of polymer bulk material?
Yeah,
So,
it's a flow cup only.
so melt index it won't come, no.
No, no.
So that also will give a flow behavior, no. But we have got one more answer only we can tick. Okay, so I had a doubt for that.
Okay. So for
Okay,
flow
okay,
cup measurement itself, there is different types of like standards again available. Flow cup for polymers. Okay.
okay. Because
Yeah.
in the class, no portability was mentioned, but how to measure it was not told, sir. So we had a doubt. Okay. Thank you.
Hmm. Yeah. See, the difference between porability and melt flow is that in melt flow, basically you are melting the polymer and you are seeing how it is flowing if you are applying some kind of pressure to it. Okay.
Okay.
Yeah. So basically that's how you are doing the thing. Flowability measurement. But sorry, that is how you're doing for melt flow. But in pourability, you're basically using a flow cup to measure the pouring ability of the polymer itself.
Oh, fine. Okay. Understood.
Yeah.
So one more doubt. So actually, previous assignment. Can I ask a question now, sir?
Yeah, you
Is it
can see
possible?
it like the
Uh,
questions which we discussed
Actually,
in
one
class.
of the question which we have discussed last time, no, so that is the defects in injection molding, no. We were
Hmm.
discussing that doesn't come under injection molding defect, no. But
Yeah,
in the answer when it came, no, flash was one of the defect. That was the answer which we got. Okay.
in injection
So can
molding.
you please clarify? Yeah, injection molding. Actually,
Yes, yes.
we have.
Actually,
Okay.
okay, I'll explain that. I'll explain to you why it is there
Yeah.
like that.
Because we were
Okay.
telling compression molding, a flash will be an error, but
Yes.
injection is not like that. We discussed that time, no, sir.
Yeah, but the thing is, basically, it will behave in a similar manner. How that would happen is, for example, if when we are injecting the polymer inside the cavity of your during the injection molding process, similar to how the compression molding process is providing force and putting out the extra material outside, that extra material is flash. Okay. So similarly in injection molding, when you are pushing the polymer into the cavity, extra material can flow outside on the sides also. So that is again like flashing.
Oh, okay.
Yeah.
Okay, sir.
So the thing
Yeah.
is, it's not directly understandable. So that might confuse you sometimes.
Uh, Actually, sir, there is one
Okay.
delamination is also there.
Sorry?
Yeah, delamination is also there.
Delamination, right? Yeah.
Yeah,
Delamination is also
but
there.
that was not the correct answer, because that is also possible in the injection molding materials, where multiple materials are there, and if they are not mixed properly or moisture are there,
Hmm.
so they may be having in 2 3 parts, they can have the layers of formations also among that.
But see, this is the case for a mixture of two, three materials, correct?
Yeah, that is okay, but that is a part of a injection molding, na?
That is part of the injection molding. But I guess they were talking
If
about a
moisture is,
single.
if certain time moisture is also coming, so that
Hmm.
is also forming one layer in between that, which can be termed as ki there is some delamination is being taken place.
Yeah. See, the thing is, I think in industrial scale, all of those factors will affect. Frankly
Yes,
speaking, I think that. But I
yes.
guess for only the sake of course,
Oxidation will can also come, but that is coming when the product has been made,
made.
and after
Yes.
some time when it is being provided the environment where the oxygen is there. After some time, UV effects and the oxidation is taking place, so some discoloration is also coming. But that was the long-term effect.
Yeah,
But
that's a long
delamination,
term effect.
flash, warpage, sink marks,
Yeah.
those can be immediate or within a after some time effects are there, short-term effects.
Yeah, yeah. That's an immediate effect. Warpage,
Yeah.
sink marks, and all those things, they are quite direct effects, and it
Delamination may come, but this will be just after some time, just like a warpage is there, na sink
huh,
mark
huh.
or warpage is there.
Yeah,
So at the same time, delamination can also be occurring, but oxidation is a long-term effect.
yeah, definitely. Oxidation is a long-term effect. It's like the effect of aging or the degradation of polymer with
Yes,
time. So that will happen as well. So exactly in industrial scale, if you were to see that all the rooms
but
and all the
delamination,
places,
but delamination can also be one of the part.
hmm,
Whether this is the option is there.
yeah, delamination can be one of the parts, but as you just said, that it will be applicable for a mixture of materials. But I guess the
No,
context
not
was
mixture,
that
even moisture. If moisture is also there in the material when we are processing.
moisture is also there in the material. That is there.
Yes.
That is true. Okay.
And if you are saying low tooling cost for injection molding, the
Huh.
tools are the higher costly basically.
Huh. The thing is,
So
initial
that
cost is
answer is
high.
also one of the issue with that.
No, but initial cost is high. But after that, once you spend initial cost, then I guess it will be
But
fine.
injection molding will never be a part of low tooling cost because if the patentation, if any materials are we are seeing,
Huh.
so it is also it's seen low tooling cost word never was used.
So low tooling cost won't be a part of that.
Yeah, this will not be a part in that.
Hmm.
Because once you are saying for the primary advantage, na,
Yeah.
so primary advantage low injection molding we are using for a higher production rate in the injection in
Huh.
the industry, and
Yes.
once it's for the higher, so means the tool which is known as the mold, it should
Mold
be a costly one so that it can sustain for many numbers of shots.
cycles. Yes,
So
exactly.
if it will be there, so automatically low tooling will not be there.
Yes, but I think that is definitely there. So that is basically the initial investment in the material itself.
Because
So I
certain
guess.
time if you will see compatibility with materials, so
Hmm.
it may because in injection molding we are also doing some metal insert molding also.
Insert
If you
molding
have
also,
seen
right?
some
Yeah.
battery lids, any other things where metal inserts are also there,
Yeah, yeah. They are made from
that
that.
is also
Yes.
with the compatibility. Injection molding may compatibility hai because it is being used as an insert molding,
Insert
but
molding.
at the same time molten material in metal condition will not be applicable.
Yeah, molten material. Yeah, that's what we were not talking about molten metals in
But low
that
tooling
condition.
cost can will not be answer for the same.
Yes, but I guess it
Because
was mostly in comparison with the others, I guess. So definitely
if
the
you compare
comparison
with
will be,
others, na, injection molding mold material is higher costly than other techniques.
yeah, mold material is higher costly than the other techniques, but that's only for the initial phase. And after that, once you invest in that much maintenance won't be required. Yes. That was the main, I guess, the takeaway from that.
Hmm.
Yes.
So this is these
Reshmi,
are two points where delamination can also be added and low cooling cost can also be removed.
removed.
That
Yes,
both
yes,
the issues are
definitely,
there.
definitely, it can be done. Reshmi, you have raised your hand again.
No, 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 sorry, sorry, that was by mistake, sir. Sorry. Yeah.
Oh, okay, okay. Okay. So, yes, I guess we had a good discussion about those things. And today's class is basically over. So we can only discuss these many problems. And I guess the rest of them you can do by yourselves. And that might be present on the course material itself, in the course material itself. And as we already can see that we are more than capable of finding these things out by ourselves. So we can answer them by ourselves also. So
Uh,
th thank you very much. If you
sir,
have, yeah,
Thank you.
this
sir,
is.
can you discuss the second problem because I missed that part?
Oh, okay, okay. Discuss it. So the first one was this one. Second is again this one. That is the direct shaping process used for preparing the test specimen? The answer for this is injection molding, extrusion, and the compression molding process. As we know that by injection molding, you are directly injecting the molten polymer into the example, the test specimen specifications are there. You can inject your polymer directly into the test specimen mold itself. So you will have the uh, directly shaped polymer material ready for the testing. Similarly, for extrusion, when we are extruding the polymer, if you are to change the die dimensions, the die through which the polymer is being extruded, that itself can also give you the testing specimen directly. And similarly, for compression molding, you're simply pressing the polymer flat and the sample can be generated for the testing specimen. But in case of blow molding, what happens is that blow molding will create, for example, in blow molding process, what happens is you have a small parison, and that parison is injected with the high pressure air, and the heat is generated in that. Heat is heat is applied, so the polymer melts and occupies the entire cavity. So blow molding process is used for manufacturing, what should I say, close-ended products. And because of that, what happens is the the testing specimen is not generated as it is for mechanical testing samples. So even in our lab, we are generating a few materials using blow molding process. And because of that, it is not exactly test specimen ready. And we have to make some further manipulations to create a test specimen ready. So the direct shaping process for test specimen ready materials can be injection molding, extrusion, and compression molding. I hope I was able to clear that doubt for you.
Yes, sir. And another
Possible,
one.
sir, slides, all the slides, can you please just have a look so that because I've joined recent lately.
Oh,
So
okay,
if
okay.
possible, just give me 30 seconds so that I can read the slides which are there. First one and 10 second has been completed.
Yeah, one and second has been completed,
Uh,
and then we have the third one, which is used for tensometry measurements. We have the tensile testing machine because we are applying the tension in the.
Extensometer
So
is there for the tensile only. Elongation we have to
yeah,
measure.
yes, that is the thing. Then we go to the rheometer. What are the different types of rheometers commonly used for material characterization? We have capillary,
Mm,
rotational, and oscillatory. Dynamic
okay.
mechanical analyzing technique is a technique which can be used in rheometer, but it's not a rheometer itself, it's a
Yeah.
measuring technique.
And UTM itself is not a rheometer
Yeah,
application basically.
so that is
Mm,
another thing. And similarly, same to that, the rotational rheometer can simulate and measure flow behavior. It's true under various shear rates. So that is also there. And
yeah.
then we have the hardness test is a measure of polymers resistance to indentation or scratching. The
And there's a
durometer
resistance to indentation basically. Hardness is the resistance to indentation or resistance to scratch.
scratch. Yes, correct.
Yeah.
Exactly. And then the last one we have is which figure of merit is used to measure the accuracy of a measuring system
The
is
bias
the
is the correct one.
bias is the correct one. Yes. So these are the questions which are discussed today.
Mm. And this will definitely help to solve out some assignments also as well.
Yeah,
Because certain times some dilemma questions will there.
yeah, definitely. Many dilemma questions are there. Yes, and
But actually,
some.
the two questions which we have discussed,
Hmm,
those are having some different points also because delamination can also be a part of that.
hmm.
And injection molding is basically with the high cost tooling. That is the low cost tooling is not a special word for the same.
Yes, exactly.
Yes, sir. For a same, for a delamination, what
Hmm.
I thought just whenever we inject a material in a mold and allow them to cool, so initially the part that is just in touch with mold, it will get cooled rapidly rather than the internal part or
Yes,
part in
yes.
center.
Yeah.
So due to uneven rate of cooling, there may be a chances of forming a layer that will create a delamination.
Yes,
Yes,
that's the
yes.
case.
That is the case. Correct. Because we know that polymers are thermal insulators, so the cooling is non-uniform. So,
But that will be that the same condition will be associated with moisture only because in the simple material, if everything is okay, so delamination
hmm.
normally is not taking place.
Yes.
Mm. Yes, sir, I agree. Most of cases, practically whatever I seen that when you start a machine, so
Yeah.
starting within a first or two or three specimens are having such kind of
Yes,
problem. So
Hmm.
we keep them inside
Yeah.
rather than going let them go into the market. And
Market.
the
Okay.
Yes,
Definitely.
same way. Likewise, if for the sir earlier told about the cost of molds for
Huh.
injection mold,
Yes.
because if you see any PPT or something like that about the injection molding, they are saying that the cost of molds is the major principal cost
Major. Yes, yes.
for injection molding
I
machines.
guess that is true for many kinds of the polymer shaping manufacturing processes also. That mold is the
Yes.
one which takes a lot of cost. So that's
Yes,
one
yes.
part.
Recently, some of my group has joined about some MSME groups,
Hmm.
created a PPT for that, and they are also mentioned that kids to start a injection molding process as MSME is easier, but
Yeah.
the main major cost involved in is the cost of dye that required to start one product.
Yes, yes, exactly. The cost of dye and all those parameters are very
In
important.
most of cases, like just if you keep an example of chairs, molded chairs,
Huh.
so in many cases we in India we are not creating that big dies for chair or something like that. In that case we have to import that dies. So
Dyes.
most of big brands, big companies are importing that dies for their first use, and
Huh.
they are after multiple time of use they are when their model or they are keeping that product from their product line, so then they are selling that dies to a small producers,
Producer,
like
yes.
smaller brands, and then
Hmm.
smaller brands are starting using that dies, because initial cost of that original time of design, first copy of the design is very costly, so small brands can't afford that to buy them originally, so they are
Certain time
in.
more than 1 CR, 2 CR, even 3 CR also.
Yes, yes,
Huh.
yes.
At the cost
Yes.
of
So
the machine, at the same time, the cost of the machine will be around 1.5 CR maximum.
1.5 CR. Okay.
so that's why, sir, the recycling material user or small producers are using a second hand dye to produce that
Hmm.
product.
Yes, yes. So,
The weight of the die is also 2 ton, 3 ton minimum.
yeah, the weight of the
Yes.
dye is very high. Yeah.
So that's why the low cost tooling will not be a suitable answer for the same.
I mean, that is true because I guess if we were to take a look at all of the factors, definitely all of them affect the manufacturing process in some way or the other. So that is definitely true. And in industrial scale, we have to take care of everything, moisture,
Yes.
delamination, everything. So everything is done in a controlled manner. So I guess that would be the main answer for that from a very practical point of view. But I guess for
Yes.
only for the course sake, it has been written it out like that. Somewhat
Very good.
misleading.
Yeah.
It has always been like that, that we learn few things in school and then when we go to the industry we find out that it's a different game.
But due to that, actually, the marks is getting deducted, na?
That is true. Yes, yes. Sir, so where are you from? I'm seeing you first time, I guess, in class.
No, actually, I have just joined very first time, but I am listening your all the videos.
Okay.
I myself, Abhishek Rajvansh, I am from the Central Institute of Petrochemicals Engineering Technology,
Yeah, separate. Yes.
and yeah, SIPET. And if
Okay.
plastic industry is there, so from operator to even senior persons are from the SIPET alumni only.
Okay. Okay.
So we are teaching the student these techniques basically.
Oh, so okay, okay. Got it.
Yes, sir. Yes, sir. I have seen a one CPET center at Haldia, West Bengal.
Yeah.
Yeah, yeah. Haldia has separate, yes. Definitely.
So we have the around 40 locations all over India.
Okay.
We have around 40 locations all over India. I am at Dehradun station.
Okay. Okay. Nice to meet you, sir. Nice to
Yeah,
meet you.
thank you.
Yes, sir.
And the discussions should be healthy, and actually these points are basically things which we are teaching to our students also.
Yes, sir. Yes, sir.
And we are
Exactly.
not getting marks for the same being teacher.
Exactly, sir.
Now you can understand the problem.
Exactly, sir. Yes. Yeah, healthy discussions will give us more knowledge. That is the point. Yes. Okay, sir. So today's class is over, I guess. Good to have you here.
Thank you, sir.
Yeah. Thank you very much. Thank you. Sir, okay, then I will close the meeting. I guess class is over. Thank you, sir, very much.